everybody. So I introduce myself. My name is Mohamed Mahdi Ben Issa. I'm a big data technical architect at Crédit Agricole Group Infrastructure Platform and big data technical owner for Crédit Agricole Corporate Investment Bank. I will let Abdelkrim introduce himself.
Hi everyone, Abdelkrim Majid, solution engineer at Cloudera, mainly working with financial and manufacturing customers.
Okay. So today we'll present the disaster recovery experience at Crédit Agricole Corporate Investment Bank. So I will introduce Crédit Agricole Group Infrastructure Platform, which is the IT production arm of the Crédit Agricole Group. Today we are managing around 80% of the Crédit Agricole Group infrastructure. We are around 1,500 experts managing the different IT service offers of Crédit Agricole Group. So in my team, we are 15 big data build and run experts delivering big data service offers and platforms for Crédit Agricole Corporate Investment Bank. So today we have a build and run team between Singapore and Paris, and we are managing a platform with around 8 petabytes of storage, 36 terabytes of memory, and 4,000 cores. So the principal use cases that we are implemented today are cash management with a pure transactional approach. We have also risk management with a decisional approach. We are also some projects with regulations needs like FRTB and MiFID, and we are working also on the modernization of our decision-making platforms. So the two biggest projects are risk management and cash management. So the first one is implemented with a decisional approach. The idea is to build risk reports with real-time, on-demand, or scheduled approaches. And we are managing around 3 petabytes of data on production today for this project. We have a second project, which is the cash management transformation. So this platform is full transactional. The target of these projects is to manage around 8 million transactions per day, which is equivalent to 8 terabyte of transactions per day. So this is the architecture of our service offer. So this architecture is implemented with the Hortonworks data platform technologies. So we are supporting many technologies like HDFS, Hive for the storage layer. We have also Kafka for the messaging needs. We support also different stream processing engines like Apache Spark for batch processing and Spark Streaming and Storm for event and stream processing. We are also providing our customers with other technologies like HBase and Druid.io for the serving layer. And we work to integrate Apache NiFi for the data collect phase. So in this slide, we have the different challenges that we have when we implemented and designed our platforms. So we have to work on the different disaster recovery topics. So today, the goal is to have a different platforms which are available 40 per 7/24, and to avoid the data loss on our platforms. So we are working also on different performance topics with respecting the big data approach and best practices like data locality and in-memory processing. And we have also another challenge, which is the security. So today we have automatic authentication via Kerberos. We are managing the authorization and audit part with Apache Ranger, and we are supporting the data protection via data encryption. I will let Abdelkrim present different architecture for disaster recovery.
Thank you. So before going deeper into what CACIB has done in their architecture, we wanted to cover different approach to disaster recovery. What are the pros and cons in terms of architecture, in terms of SLA that we can get before getting into details of CACIB tools. So just quick reminder, I guess everyone is know the difference between these topics, but it's always good reminder in the beginning. So here we'll be focusing on mainly disaster recovery. It means there is a lot of risk into your big data cluster or application. You have risk of failing disks, failing nodes, and for this you have high availability. You have risk of failing a full data center. So for this you have disaster recovery. So what are the approach that you are taking to don't lose data or service? Depends. There are two things around this in case of disaster like fire or electrical failure or this kind of things. And after that, you have the risk of someone deleting your data. So for this, you have other solution, backup and restore. And for some requirement regulation needs, you need to archive your data for like 5 years, 10 years, depending on the use case. So here, we are focusing mainly on disaster recovery. It means that we need to be able to not lose data, not lose our services if the full data center is lost. So in terms of approach, the first thing that you'll be doing is defining your SLA, Service Level Agreement. And there is two main metrics around this. And the second one is the most important for CACIB in this case, which is RPO. It's the maximum amount of data that you accept to lose in case of disaster, measured in time. It means that if they have a problem and all my data center is lost, I may accept to lose 5 minutes of data, 1 hour of data, 24 hours of data, and depends on the use case. After that, you have another key parameters, which is the RTO, is the acceptable amount of service and availability. This means that, okay, maybe I don't want to lose data, but I can lose the service for 24 hours or 5 hours. I will give the opportunity to the team to bring the service again in another environment. So we will have to minimize these two KPIs, but try to minimize also the impact on the performance of the different solution, reduce the cost. If you need to have like very expensive hardware that will be higher than your platform, yeah, there is problem in your approach. So in general, there is two approach for disaster recovery that we are seeing here. The first one is dual ingest. Like you are getting data, you are storing it in 2 clusters deployed in 2 data centers, and if you lose one, you have the second one to use. This gives you low RPO. For ourselves, it's again, it's the most important parameters because you are data ingested in two data centers. So if you lose one, you already have the data in the second one. You have mirroring, which is the most used approach with Hadoop and big data systems in general, where you have this L replication. It means that you are ingesting your data in one data center, and after that, schedule replication, delta or full, from one data center into another one. So it means that if you've done your replication like 30 minutes ago and your data center is lost, you will lose 30 minutes of data. Maybe it's in other systems and you can bring it back. But if we focus on this platform, it's not there, even in the replication part. So this is why it has higher RPO, but it's easier to set in place. And finally, the approach that CACIB has took is deploying one cluster on multiple data center. So what we call stress cluster or the multi-data center. There are a lot of pros and cons. It's not solution for everyone. There is several things that you need to take into consideration to deploy this kind of solution, and this is what we'll details after. So, as I said, the first approach, dual ingest, just getting data ingested with different tools, storing it in 2 clusters. It's really easy to implement with tools like Kafka or NiFi. You can do the Y ingest into the 2 clusters. Your application is in the other side. You have load balancer that's aware of your infrastructure and your architecture, and will use the available one. So in terms of pros and cons, the biggest advantage is very low RPO. It can be 0 or almost 0. You have dual run. It can be at pro, but also as cons. So it means that you have two clusters running in the same time, and it means that you have double work to do, but your disaster recovery is first-class citizen. It means you are monitoring it, you are testing it every time, all the time. Where in the replication, it's like second class, so you don't focus on it. You try to do tests from time to time, so you maybe catch up something that you missed in the beginning. As I said, it's easy to implement with tools like NiFi or Kafka. And again, this last point is maybe pro and cons. For me, it's pro, but for a lot of people, it's cons. Because when you implement this, you need like a synchronization layer between the two to check if your data is exactly the same between the two clusters or the two applications. This means that when I present this to customers, they said, okay, what happens if I have the same data ingested, I have the two applications running, but I have two results which are different. So here, it means the problem is not in the architecture, the problem is in your application. It means that you have missed something, you have not tested everything, and you maybe need to go back to the developer and see what they did. So it will highlight more problems that you maybe missed. So it's a good thing. This is why I put it in the pro part. In terms of cons, yeah, it will require two clusters which are almost ISO in terms of performance because you see them as two production clusters. And you need to have almost the same configuration. Configuration is very important because if you do something in one cluster, you need to do the same thing in the other cluster. So automation is key here because you don't want to change something in case of emergency in one cluster. Don't do it. And when you deploy new application, you see that there is a difference and it's impact your application. And finally, yeah, you need this cluster diff implementation, which is mainly implemented at the application layer. It can be simple counting or more advanced approach to see if there is difference in terms of result and you have this consistency. The other approach is mirroring and just in the first cluster, serve it as first active data center. You replicate data from time to time, and if there is problem, you file over to you file back to the second data center. It's very simple. It's almost the most used approach. It's really easy to implement. You don't have like any advanced requirement in terms of infrastructure or any kind of configuration. Hadoop have been designed for this kind of architecture. So if you looked at different vendors, this is what they do by default. You have better performance because you are local to one data center, so you can optimize everything. And also that can be used for other use case. So we have a lot of customers that use disaster recovery cluster for doing like data science or maybe serve customers that are geographically close to this data center and so on. So in terms of cons, you have two clusters, high RPO, because yeah, if you replicate your data each hour, it's 1 hour RPO at maximum. And you need a replication tool or layer. But the biggest cons here is you need to define file over and file back. This means what I do when my first data center is not available. This is not the most complex part. But when my first data center come back, I have maybe did some change here, how to get back into consistent layer. And sometimes you need to stop things to reschedule it. It's also really important to think about the whole stack. Here we are mainly focusing on data, but you have your application, how to deploy them, your configuration, your infrastructure, and everything that's beside your cluster, like your process, your Active Directory, your LDAP. Everything needs to be replicated and synchronized. Otherwise, you will have funny things to deal with. So there are a lot of tools that you can use for this. Like from the legacy Hortonworks, we had DLM. From Cloudera, we had BDR. Both of them are based on things that exist in Apache Hadoop, like DCP. So it's mainly like parallel replication of data between two HDFS. Some of customers want more synchronous replication, so they use things like NiFi, where you can listen to an HDFS path, and every time you have new file created, you get the metadata and use NiFi to consume it and send it to the other data center. We have also you have often the question is, okay, you are talking about maybe 1 hour RPO. Can we do better? and sometimes the comparison stay only at the software layer. Can BDR or DLM do better than 1 hour RPO? And the answer is not really in the software. So it's true that there is things that are in the software that will impact this. Mainly, what are the different steps that you do before replicating, like compressing the data, doing snapshot, maybe encrypting it before sending it. And if this kind of things can take time, and you cannot get 0 RPO. The data that you have is also important. What's the maximum peak of data ingest that you have? If you receive like 2 terabytes of data in 1 second, but your network cannot replicate it to the other side, so you cannot replicate it. It's like physics limitation. So finally, the most important part is the infrastructure in terms of bandwidth, latency, how many reserved bandwidth do you have. All this aspect will impact your RPO. So it's not only a question of software, of tool that you are using. So mainly, at the end of the day, you can like modelize this as function, which take 2 important parameters. The first one is the maximum data burst that you are generating, and the other one is the available, here I write bandwidth, but resource in general. The last approach that CIB are using is stretch cluster. This means that you have 1 cluster deployed over different data centers. So here what we are talking about is not the US way of stretch cluster. It's not 1 data center in East Coast and the other in West Coast. Here we are talking about data center in the same city, far by 10, 20, 30 kilometers. We have dark fiber between them, so we can guarantee bandwidth between them and latency. So don't take it as general stretch cluster where I deploy on the cloud, on-prem, or maybe between 2 cities and hope that this works. It doesn't work. So we will detail all the requirements here. There is also, as you can see, 3 data centers, not only 2. Midi will discuss this point later. And take into consideration, it's not native in Hadoop, so there is some configuration that you need to do. So in terms of pros, it gives you better RPOs. It's cheaper because you have 1 cluster. It's simpler because it's 1 cluster spanning different data center. So there is no need to define failover and file back. But there is cons too, as all the other approach. The first one is there is very strong constraint that you need to have. As I said, nearby 3 data center for everything quorum like Zookeeper, journal node, and so on. The latency should be at maximum 1 digit millisecond. And you need guaranteed bandwidth. This is very important because when we discuss with customers, they often say, yeah, we have good network, but yeah, how much is reserved for you? And what's the peak that you can get? And this discussion will change after that. There is a lot of advanced configuration that Midi will details after. It's not, as I said, if you take like HDFS by default, you create a block, even if you use like awareness, you can end up in a situation where you have all the data in 1 data center. And when this one is broken, they will have like replication storm where we try to get back to 3 replica, and this is bad. Performance impact by data center networks. So keep in mind that even if you have dark fiber, this will impact your performance of application depending on the network. So you need to take this into consideration. So it's a balance between, is it more important to have this RPU or the performance? So maybe it's not optimized for use case like streaming with NiFi or this kind of things. And let's move to the details of trust.
Okay, thank you, Abdelkrim. So, in a financial context, and especially for a corporate investment bank, the most important parameter in the service level agreements is the RPU. It means that we don't lose data in our platforms. You can imagine that, for example, for our cash management project, if we lose 1 transaction, it can be catastrophic for the bank. So, for this reason, we designed and implemented the stretch cluster, which is 1 cluster deployed across 3 data centers. So all your profile nodes, node profiles will be deployed across the 2 data centers except the witness node. So we'll have your data, master, control, and administration node deployed across DC1 and DC2, and then you will deploy just the witness node on the third one. It's just for the quorum logic, and this deployment will avoid the split brain scenario. Is that you will never split your cluster to two different clusters. So I will give you more details about the implementation of the storage cluster for HDFS. So as you see in this figure, we have our different data nodes deployed across two data centers in different racks. We have two name nodes, one name node per data center, and then we have the different witness nodes with journal node and Zookeeper deployed across three data centers. As I said, the idea of this deployment is to avoid the split brain. So Zookeeper will give us this feature. So between DC1 and DC2, we have an inter-DCs link with 100 gigabit per second as bandwidth and with a latency less than 1 millisecond. So with the default configuration of HDFS, when we put a block or a file, the block will not be well replicated between different racks and data centers. So in our concept, the idea is to have just one block per rack and 2 blocks per DC. So for this reason, we added the rack awareness configuration. So the idea is to tell HDFS about the topology of our cluster by defining the rack of each data node. So with this configuration, it's better, but it's not well replicated also. So after this, the next step was to add there is another problem with the rack awareness configuration, is that the default behavior of HDFS is not the expected one. It means that HDFS will place the first block in the closest rack, and then we'll place the second one in the second rack, in the remote rack. The third block, or the third replica, will be in the same rack as the second one, and then finally, the final block will be placed randomly. For this reason, we applied a very advanced configuration, which is the topology awareness or the data center awareness. It means that we will enable some parameters to activate the network topology with group configuration. We'll change also the class of the replicator by setting it to block placement policy with node group. We did also some adjustments just to reduce the RTO. It means that we changed some timeouts in order to have an RTO near by 0. And finally, we enabled also the best effort behavior in the DFS output stream in order to have an automatic failover for HBase and Flu. Because HBase and Flu are using the DFS output stream class natively. So now with this configuration, you can see that you have exactly one block per rack. So that's perfect for our case. And also, when we lose data center, you will see that HDFS will not try to keep a replication factor of 4. So it's perfect. It means that we will not try to replicate 4 replicas per DC, and it's very important in our case. So let's switch now to Yarn. I will give you more details about the Yarn configuration and architecture. So it's the same approach. We have different node managers deployed across DC1 and DC2. And then we have 2 masters, which are resource manager, deployed in the DC1 and DC2. And finally, Zookeeper, it's the same service which is deployed across 3 DCs. So it's the same thing for Yarn. We added the node group configuration, and we did also some adjustments in order to reduce the RTO. So with this configuration, it works. It's okay, but you can imagine that when we deploy your jobs like Spark jobs or MapReduce jobs, you can have your containers deployed across the two data centers, and it's not a good thing because we are not optimizing the inter-DCs link. So you can do shuffle operations across 3 data centers, and it's not very optimized. So in order to optimize this part, we added a node label configuration by defining 2 node labels, the first one for DC1 and the second one for the second data center. And with this configuration, we can now deploy an application on 1 data center. So we can choose between DC1 and DC2. And with the node label expressions, we can say, I want to submit my job in DC1 or DC2, or you can define other expressions or other needs. So with this approach, you can imagine if we lose the first data center, Yarn will do the failover automatically by submitting your job in the second one. So for the conclusion, in order to validate this architecture and configuration, we did many tests. So we did many tests by simulating the disk, node, rack, DC, and inter-DC failures. We did also the test of the split brain. It means that we simulated the inter-DCs link failure, and thanks to Zookeeper and journal node configuration, we are sure that today that our cluster will not be split into 2 clusters. We did also the same work for the other technologies like Apache Kafka, Embari, Storm, Embari Matrix, HBase, Ranger, and for all the other technologies in the HGP stack. Also, we validated this approach with our customers, and it's very important to have also a very advanced monitoring in order to complete your architecture. Before questions, I want to thank my colleagues at Crédit Agricole Group Infrastructure Platform and Corporate Investment Bank. Special thanks also for Abdelkrim from Cloudera, Diana, Olivier, for their help and support during this amazing big data experience. Thank you very much. Do you have any question? Yes. That's okay. So in our case, we are supporting many type of failures. It can be one node failure or the failure of one DC. And we had this case last year. We lost one DC, and it was very critical for the bank because we have very critical applications like the cash management one or the risk management. So we cannot accept the fact that the application or big data application will not be available in this case. So that's for decision? Yes. Are you not looking at continuity, like the earthquake or some natural disaster in that whole region? Yes, that's the case. We are talking about natural. So this is related to the regulation constraints that we have in a financial context. And today we don't have some constraints to have different clusters deployed across different cities. So yes, today we don't have this constraint. We have a distance of 30 kilometers between DCs, and it's acceptable in our case. So we lose the application, and it's acceptable in our case, yes.
If there is big disaster in Paris, yes, the 2 data center will disappear and we lose data. But for this is something that we are discussing for future use cases. It can be combination between this and the remote cluster, but in this way you need to do replication because this doesn't work as on long distance.
power, fire, wrong configuration.
Flooding, we have a lot of
Very important
customers
part.
that lose
We had the
machines.
case last year.
Yeah.
That's it. Yes. As you like. Yes. So this is not, with this configuration, we implemented also other solutions like data and configuration backup. So today we are doing the backup of the entire cluster configuration, and we are using also other solution in order to backup your data once per day from our clusters to another technology, which is IZLAN. So
as I said in the introduction, here it's disaster recovery. There is archival and there is backup, which are other topics. And whether you use this or mirroring, you need something else to protect from someone deleting your data.
Exactly. And I think that is the case with the other architectures also, so we have the same constraints. Yes. It's not dedicated, but we are defining many rules in this interdices link. And today, for our case, it's acceptable. So the highest peak was around 30 or 40% of usage. So it's very acceptable. It's a shared, but not shared with the. It's dedicated to corporate investment bank. So we have our other applications that. Like that relational databases, etc. And today it's acceptable, but sure that tomorrow if you need more bandwidth, so we have to dedicate another link. Yes. Yes. I think that's a question for you.
So here the objective is really to have almost zero RPO. Or zero RPO, and if you are doing mirroring, even if it's not in like active fashion, you won't get that because you need some time to do the replication.
Yes, but it's true that today, for example, Apache HBase is supporting the synchronous replication thing that was not supported when we designed and implemented our architecture. But it's not supported by HDFS. So today you cannot have a synchronous replication with HDFS. Yeah. Yes. 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 Yes, because HDFS will default will do it, but when you apply this configuration that we presented, with the node group feature, HDFS will not do it. And with the block replicator class that we changed, HDFS will not do it. So the constraint is that we have to keep one block per replica, and not more than one block or replica per rack. So yeah. I can show you in the configuration font. No, that's all. For the configuration, that's all. And it's natively integrated in HDFS, and you have not to implement or to develop another replicator. So, yes.
There is also other replica placement topologies that have been added in Hadoop 3. For instance, there is one where you say for each block, the delta between the different components or racks should be at most one. So in this case, if you have like 3 data centers where you need to use data nodes on all of them, if you put first replica in first data center, you put the second in the second one, the third one should be in the third, because if you put it on the first or the second, you will have 2-0, which break the rules. So you have this kind of rules with different placement strategies.
Three questions. Yes, so for streaming is very special. So today, for cache management, for example, we have a storage cluster with Apache Kafka and Storm. For Kafka, I don't know if it is the best choice, but Apache Kafka is supporting this architecture. You can find more details about the storage cluster configuration in the definitive guide of Apache Kafka, and I can say that maybe it's not the best approach because with HDFS you have a pipeline for your replication, but with Apache Kafka you have another approach with one leader and many followers. So maybe it's not the best approach, but today we don't have the choice. Or, for example, for cache management, we can't accept the fact that we lose transactions or something like this. But it works. Maybe we have some performance impact today. As I said, the highest peak in our inter-disease link is around 30%. So today everything is okay. Maybe for new needs we have to upgrade this link, or we have to think about other optimizations. But it's not the case today. Thank you.
For the streaming part, there is big part of which is based on node labels that you cannot get with Kafka Stream, Storm, or the different streaming engine. So you cannot optimize the processing part, so there is performance.
Yeah, so you can run your Storm application on one data center, for example, and then when you have a failure, you can run it in the second one. It's fully automatic, yes. It's managed by Yarn, so Yarn will do the failover for you. It's automatically managed in Yarn. So you can imagine also without a storage cluster, when you lose one container, it can be the application master or one executor for a Spark or driver, Yarn will do the failover automatically in other nodes. And it's the case also for with the storage cluster configuration. Okay, because without this optimization, as you see in this slide, without this optimization, you can have different containers in different data centers for the same application. So you can imagine that you have two executors on the first DC and two executors in the second one. And in this case, the usage of the inter-DCs link is not optimized. So it's better to submit your job on one DC. It works, yes, but maybe it's not well optimized. Yeah. Do you have any question? Thank you very much.
Thank you.
Thank you.